Hello everyone, my name is Yunchong Liu. Today I'm going to talk about the skin effect with you. So what is skin effect? Well, skin effect is a phenomenon where you can observe the alternating current traveling through the surface of the conductor instead of the center. So in order to understand this phenomenon, we need to have some basic background of the inductance. So now imagine we have a wire lying on the ground with an applied DC current flowing through the wire. From what we have learned in class, we know this DC current would induce a magnetic field on this wire. So if we suddenly increase the value of our DC current, this would increase the magnetic field around the wire, and through the Faraday's law, we know this increasing magnetic field would result in a current flowing through in the opposite direction to the original current. So now the net current would be zero. This is what happened at the very first instant of the time. Then, at the very next instant of the time, the magnetic field decays slightly, so the opposition current would also decrease. Now the net current will now be equal to zero. We have currents flowing through the wire. So this process will continue happening after enough time passing. Finally, we can observe the full current flowing through the wire. So this is how the inductance can have impact upon the wire. Now let's see, what if we change the direction of our original current halfway through the process? Well, if we do that, this DC current will become an AC current. If we do that, we change the direction of current, the whole process will start all over again, like we get a zero net current, and then the net current would increase gradually. But all of those things are happening in the reverse direction. So the number of times the original currents change direction each second is called frequency. If the frequency is high enough, which means we change the direction of current so quickly that no current will be allowed to flow through the wire. In this way, the frequency must be super high, crazily high, which is impossible in our real life. One question is, during the period of time in which the magnetic field is decaying, where does the current flow? Let's recall the Ampere's law, which tells us how to calculate the magnetic field intensity. And through this equation, we could see that the farther it is away from the center, the smaller the magnetic field intensity would be. Now we also know the currents flows where the magnetic field is weakest, so the currents tend to flow strongest the farther the distance from the center of the conductor. We can observe the current flowing near the surface of the conductor. So there are three possible reasons we can think about skin effect. The first one is the inverse relationship between the resistance of a conductor and the cross-sectional area. The second one is that the skin effects can cause the resistance to become a function of frequency. The third one is if the skin effect could increase the resistance of the conductor, then this conductor will heat faster and to a higher temperature at higher frequency for the same level of the current. So when we discuss the third condition, we'll talk about it under the AC situation. With the increase in frequency, the conductor will be easier to get heated. Now let's think about the cause of the skin effect. We know the change currents in the wire can cause a change in magnetic field, and so the Faraday's law, we know the change in magnetic field introduces the back EMF. EMF is a counter-electromotive force this electric field is strongest at the center of the conductor, so it forces the conducting electrons to the outside of the conductor. So we could observe the current flowing through near the surface of the conductor. We have two team members, Yike Wang and me, Yuncong. We are both graduate students from ECE department. As for the demo, we want to talk about it in terms of the cross-sectional area. Like if we apply DC current flowing through the conductor, the effective cross-sectional area would be the whole circle. With the increasing frequency, the effective area would become smaller and smaller. In order to demonstrate that, firstly, we would like to measure the resistance of a conductor under the AC current. Then compare the result to the DC situation, we can demonstrate the existence of skin effect. Then we want to testify the resistance of the conductor would increase with the frequency of the AC current. In order to testify that, we must apply the alternating current flowing through the wire. The higher the frequency, the larger the resistance could be. Let's move on to the experiment. Hey guys, here it comes to our experiment part. And you can see 5 things placing on the table. The left one is a DAD port which can be connected to our laptop. And this is a breadboard which we normally use in the lab. And this is a jump wire kit which can connect the components on the breadboard. And don't forget what we want to measure. We want to measure the impedance of this hex wrench. Okay, then we will go to the circuit part. Okay, so this is a circuit for our measurement. Here we found a wave generator or a DC which can supply the circuit with the signal we need, either it's a AC voltage or DC voltage. And those two sides are the positive sides of our scope 1 and scope 2. And of course, the negative sides of them should be connected to the ground. We also have two resistors here. The first one is R1, which has a certain amount of 1000 ohm. And for the second part, R2, it should be our load resistance. And this is the impedance we want to measure. So just after analyzing this circuit and do some simple math, we get simple equation to calculate our load impedance R, and this is the equation. So remember, for the scope 2, we measure the voltage of R2, and for the scope 1, we measure the voltage of our wave generator 1. So this equation can be written in another form, 1000 times C2 over C1 minus C2.
In this part, we're using waveform software to simulate our circuit and to test the impedance of AC and DC. So firstly, we are setting the wave generator as a power supply. The testing part, we're using the AC current, and which frequency is 1 megahertz, and the amplitude is 5 volts. And in the scope 1 and 2, click here. Okay, in this part we need to add a channel to test our impedance. So the test is click here, add channel, and add mathematic channel and custom. This is our function. We click OK. And we need to start run the WG1 and click run. Okay, and click the data. Okay, here because we can see the amount of the samples of data, and due to our old version of this software, we need to manually extract this amount of data and do the data processing in the Excel software. This Excel data are coming from our testing circuit. And firstly, we need to click the column A and sort the data from largest to smallest, and make sure the value are reasonable. We have to filter the data and make sure the data point the C1 are all greater than 4.95, and click the column C. We can get the average result is 986 ohms, so which is close to our known resistor 1k ohms. So the circuit is worked. Okay, in this part we are replace our testing resistors with our samples. Our sample is, as previously mentioned, is a hex screwdriver, and it can considered as a solid core conductors, which should have a skin effect in the AC current. Yeah, so let's connect it. Okay, we just simply place the conductor here.
And make sure it's contact well.
Okay. In this part, we're still using the AC current power supply, which frequency is 1 megahertz and amplitude is 5 volts. So similarly as the testing circuit setting, we still need to use add a channel called the impedance measurement, and we have set the function as the voltage divider function. And then we also need to extract this data and insert the data into the Excel as a processing. This Excel data are from the hex screwdriver AC power supply circuit, and as usual, as the previous procedure, we also need to sort the data and filter the data. And one thing we need to notice that is the column C, we have to replace this negative value to the positive value. Just make sure it's all they are all absolute value. So the final average value is 2.03 ohms. In this part, we try to test the DC impedance of our hex screwdriver. So we just disconnect the AC power supply and connect the DC power supply to here. And okay, let's back to the waveform software. So in here we have connected the DC power supply, and in the software we need to set the value of the DC voltage. So click the voltage and click the power is on, and make the negative part is off. So we set is 5 volts DC power voltage. The result is similarly has the amounts of samples. We also need to extract the data points and insert it into the Excel and get the result. Average impedance is 0.1737 ohms. In this part, we try to increase the frequency of the AC current to see if the increase of the frequency will have the impact on the skin effect. So previously we connected the DC power. So here I just disconnect the DC wire and connect the AC power supply. So let's see the waveform software. In here we just change the 1 megahertz to 4 megahertz and click the run. And also we can get this data. In this data, We also need to extract this amount of sample points to the Excel. This Excel is a 4 megahertz AC current hex screwdriver circuit, and as previous procedure, we also need to sort the data and filter the data. One thing we noticed that the amplitude of this of the AC voltage is about 4.5 volts. I think we suppose that this is because we increase the frequency, so the noise also increased. So amplitude is decreased.
So we said the filter value is 4.5. So we also click the currency and replace the negative sign to the positive sign. Make sure all of them are absolute values.
Okay, let's get the average result is about 2.64 ohms. Okay, let's see the results. So firstly, at the 1 megahertz frequency, the AC impedance is 2.04 ohms and the DC impedance is 0.173 ohms. So we do the simple calculations of AC over DC is equal to 11.79, which means the AC impedance is 11.8 times larger than the DC impedance. This is due to skin effect. So as we increase the frequency of the AC voltage to the 4 megahertz, we can see the AC impedance at 4 megahertz is 2.64 ohms, and which is larger than the AC impedance at 1 megahertz. So this means as the frequency increases and the skin effect will become more obvious.